equal natural log x, and that makes du equal to 1 over x dx. Okay, now, I have my 1 over x dx here. Now, the only other thing I need to do is x equals 1 here, so we need to figure out what u is going to equal. So that's natural log of 1, which is 0. And if x equals e, then u equals natural log of e, which is 1. So this whole thing becomes the integral from 0 to 1 of natural log x, which is u, times du, which is 1 over x dx. Okay. Oh, rats. Times du. Okay, so this equals u squared over 2 from 0 to 1, which equals 1/2. Bam! That's it. Game over. Okay. Now, the last concept is symmetry. And this is really a shortcut. Notice what we have here. If f of negative x equals f of x, then we have an even function. And an even function is symmetrical about the y-axis. Now remember, this is an integral. So if we have an area to the left of the y-axis and the right of the y-axis that's exactly the same, then I don't need to do both areas. All I need to do is half the area and then double it. So basically, if I have an even function, then I would go the integral from negative a to a of f of x dx equals 2 times the integral from 0 to a of f of x dx. Because if I have a function, like I said, that's symmetrical about the y-axis. So let's say my function looks like this. Okay, now this is symmetrical about the y-axis, so it's also got to go like this. Now, if I want the integral from negative a to a, basically what I'm saying is I want all this area in here to here. Well, these are identical. So all I'm going to do is go from 0 to a and double it. Makes my life a lot simpler, because when you're doing integration where the lower limit is 0, then generally you don't have any work to do. Putting 0 in for the x's doesn't give you any work. So watch the magic. If I put a negative in for x, then this whole thing stays positive. So basically I put a negative in and I get the same thing as if I had a positive in. So therefore this is an even function, and that means I can say this equals the integral, equals 2 times the integral, equals 2 times the integral from 0 to 2 of x to the 6th plus 1 dx, which equals 2 times, now let's do this integration, so that would be x to the 7th over 7 plus x from 0 to 2. Now this becomes 2 times 2 to the 7th, which is 32, plus 2. Now I don't have to go minus putting in negatives in here because I would just end up doubling this anyway. So I end up with, let's see, 64 sevenths plus 4, which is, let's see, that's 28. 28 and 64 is 92 sevenths. Bam! What could have gone wrong? X to the 7th over 7 plus x. Oh no! Man, today is just not my day. 2 to the 7th is not 32. It's 128. Man, that's 2 to the 5th. Ah. This is not working out today. Okay, so 128 over 7, and so we've got 256 over 7 plus 28. So 256, don't want to screw up again, plus 28, because 4 is 28 sevenths, remember. Okay, so we got 14, that's an 8, that's 284. So we have 284 over 7. Yeah, that's it. And that does not reduce, so that's a game over. All right, last idea. We said if we have an even function, it's symmetrical about the y-axis, which gives you double the area. This next one is even nicer. Okay, if we have an odd function, which means f of negative x equals negative f of x, and what that means is if I put in a negative for x, I end up with the negative of the whole function. That makes it odd. In this case, it's symmetrical about the origin. All right, so this time, my function looks like this. If I have one side going, well, let's just go like this. One side going like this, then the other side would have to be going like this. Okay, now, that's symmetrical about the origin. In other words, I could rotate this 180 and it would line up with itself. Now, if I'm taking the integral from negative a to a, then notice I have negative area here and positive area here, and it's the exact same area. So guess what? The integral from negative a to a is 0 no matter what. That's what makes this so cool. There's no work to do at all. Okay, now watch what happens over here. I've got an integral that I can't possibly even perform. There's no possible technique that you know of to do this. And then you look and you go, oh, it's from negative 1 to 1. Okay, so there's some symmetry there possibly. Then you say, well, if I put a negative in to the fourth, to the second, those stay positive. So if I put a negative into the denominator of this fraction, it stays the same. But if I put a negative into the numerator, then it changes it to negative. Well, negative over positive is negative. So in other words, this is an odd function. And since it is an odd function, it's symmetrical. And because the limits of integration are the same, now see, if the limits of integration aren't the same, then you can't do it. But because limits of integration are the same, it equals 0. So let's just do this. The integral from negative a to a of f of x equals 0 if you have an odd function. So number one, you have to have an odd function. Number two, you have to have the same limits of integration but opposite signs. And then your life is simplified. That's it. Have fun with these.